Alright, welcome to lesson 1 for geometry. Since this is the first lesson, I just wanted to show you around. So if you click here for key terms, it will pull up a new tab that has all of the vocabulary for this lesson that is bolded. So it has right here just a reference point of vocab that you can use so that you can help answer like definition type questions. The other thing that I wanted to show you is if you click this show all, it will actually expand every single one of these and it'll show you a list. So if you clicked OK, it would expand every single one of these and you would then just be able to scroll through it. The other thing that I want to make aware of is that information in red boxes are usually theorems or formulas or postulates that are very critical to the information in the lesson. So continue to look for red boxes, and if you scroll through and you see a box in so you'll work through this, and this gives you examples to use the information that it has taught you, and then you're going to select it and check your answer and then move on. So it breaks each question down into the steps that it would like you to do. And then here's an example of a paragraph proof. Be mindful that in this course it is heavily proof based, so following along a proof and understanding examples of them is very helpful. So like right here, it has a really good step-by-step of what a 2-column proof would look like if you had been in the Geometry A course previously. So again, information in red is formulas or theorems or postulates, and I am looking for information in green because information in green boxes, which this lesson does not have, information in green boxes is how you would pronounce math. So since there's not one, I'm not going to be able to show you an example of it. I will, however, help you through examples in the workbook. The workbook questions can be completed an infinite amount of times, and so I thought it would be a really good way to serve you in showing you exactly the questions and how to answer these questions so that you could then apply this to the checkpoints. So for question 1, which triangles are right triangles? Remember, all right triangles must satisfy the Pythagorean theorem. There is more than one correct answer choice. So the first thing that I'm noticing is that they have the Pythagorean theorem. And if I had not been able to remember that, I would scroll back. I would actually jump to the key terms and look for Pythagorean theorem. And it does not have it here. Another thing that you could do is to just Google Pythagorean theorem, and I always just jump to images because then I can see what is going on. So like on this, there's a 90-degree angle. This is saying this side length is A, this side length is B, and the hypotenuse is C squared. So we have A squared plus B squared equals C squared. And that is the Pythagorean theorem. They also mentioned that the Pythagorean theorem is a way to use to check and see if it is a right triangle. So what I would be doing is I would be taking this formula and I'm going to just look at this, and I'm going to say, okay, which side could be the possible hypotenuse? So which side is labeled C? Because C is the longest side in the triangle. So if I look at this, 6, 8, and 10, 10 is the longest side, so 10 is going to be C, and then it doesn't matter which one I label as A or B. Because if you noticed in the examples from our pictures, it had the example that these two could have been switched. So what I'm going to do with this is just substitute in. So since I labeled the side length that was 6 as A, I'm replacing A with 6. B is 8 and C is 10. And so now it's a matter of just simplifying. So 6 squared is 36, 8 squared is 64, and does that equal, that's what I'm checking, does that equal 100? Because 10 squared is 100. So what is 36 plus 64? That does come out to be 100. And so this one is a right triangle. So let's move on to the next one, and we're just going to be going through that. Again, if you didn't know what 6 squared was, I used the Google calculator, and this is what I use. So I would type in 6, hit this x to the y, and hit squared. Also, you could type it in as 6 squared plus 8 squared. You could type that all in. Comes out to be 100, which we did eventually end up at. So that's a good thing. So then the next question we have is 12, 14, and 19. Again, which is the longest side, because the longest side will be labeled C because it will be the hypotenuse if it is a right triangle. So 19 is the longest, and we have 12 and 14. So I'm just going to label those as A and B. And now back to our Pythagorean formula. A, we said, was 12, so I'm going to replace A with 12, I'm going to replace B with 14, and I'm going to replace 19 for C. And then we're going to jump over to our calculator, and I'm going to type in 12 squared plus 14 squared, and that equals 340. So I want to know if 19 is 340. If it is, then this is a right triangle because it satisfies the Pythagorean theorem. Since this statement right here is not true, 19 squared comes out to be 361, and 340 does not equal 361. That means that this is not a right triangle. So I would not be selecting this triangle. Let's go on to the next one. We have 5, 6, and 7. Again, I will be using the Pythagorean theorem and labeling first the side length that is the longest because that's our possible hypotenuse. So 7 is the longest, so that's C. And then I'm just going to be labeling the other two sides. So A, the side length labeled A has a length of 6, so I'm going to substitute that as 6. B is 5, and C has the side length of 7. So then again, jump to your calculator. 6 squared plus 5 squared comes out to be 61, and we are asking ourselves, is 61 equal to 7 squared? No, it comes out 7 squared is 49, so that this means that this is not a right triangle. So I will not be selecting this triangle again. So now if we look at this one, again label the longest side as C because in a right triangle that will be our hypotenuse, and then just label the other two side lengths as A and B. So again, we have A in this triangle is represented by a side length of 12. B in this triangle is represented by a side length of 5. And C in this triangle is represented by a side length of 13. So then jump back to your calculator. You would do 12 squared plus 5 squared. That comes out to be 169. We're checking to see if this equals 13 squared, which also comes out to be 169. So yes, this is a Pythagorean, this is a right triangle because it satisfies the Pythagorean theorem. The Pythagorean theorem you can only use in right triangles. So we're seeing if it comes out to be true, then it is a right triangle. If it comes out to be not true, then it is not a right triangle. So we're using that knowledge to help be a guide with that. So we have two more. We have 4, 4, and 7. So 7 is our longest side. That'll be C. 4 and 4. So we have so we have 7 as C. A and B are both at 4. So then we would check our calculator. 4 squared plus 4 squared equals 32. And up here we had 7 squared, which came out to be 49. So we know that 7 squared is 49. This is not true. So it's not a right triangle. So now our last one, we have a 3, 4, and 5. 5 is the longest side length, so again that's going to be C, and we can label the other ones as A and B. So using the Pythagorean theorem, A is representing the length of 4, B is representing the length of 3, and C is representing the length of 5. So then you can jump over to calculator if you aren't familiar with those. So 4 squared plus 3 squared is equal to 25, and 5 squared is 25. So since this is true, this is a right triangle. So then you would select it, and to move on to another question, you can either navigate here or you can navigate from at the top of it. I hope that this has been helpful as just an introduction on how to navigate the course and how to step through this problem.